Okay, lesson 88, quadratic, that should be equations, not equations, and solutions of quadratic equations by factoring. This is one of those foundational lessons that I really need you to get, and this is why we had to learn factoring so well, and we spent extra time in class on Friday going over how to factor. So if you weren't at class, pay attention to the factoring. This equation right here, ax squared plus bx plus c equals 0, is the standard form of a quadratic equation. Quadratic equation has the highest degree of a term of 2. So as soon as you get an equation and you see this squared term, you know it's a quadratic equation. If I have something like this, 3x squared plus 4 equals 0, that's a quadratic equation. If I had x squared equals negative 8, that's a quadratic equation. Of course it has no solutions, but it is a quadratic equation. Because the highest exponent is 2, it makes it a quadratic equation. We are going to solve, which means we're going to find the values for x that make it true, quadratic equations. They're going to say things like find the roots of the equations, which is another way of solving. We'll find the solutions, and that's still what we're doing, is we're just finding out what x is. Oftentimes they'll call roots, that's the same thing as solutions. We're going to do all of these problems today by factoring, and later we'll learn some other techniques on how to solve quadratic equations. So let's get started. Here we go. Here's our first one. It says solve. The first thing you want to do is put it into standard form. So we're going to do that. X squared minus 3x minus 18 equals 0. So I subtracted 3x from both sides, so there's 0 on this side, and I put it in descending order of exponents. So do that. Once we do that, then we do our factoring. So we do our factoring. I'm going to explain the factoring just in case you still don't get it. What times what gives you x squared, the x and x. What times what gives me 18, and when I subtract it, I get 3. Well, it could be 9 times 2, but if we subtract 9 and 2, we don't get 3. Could be 1 and 18, but when we subtract it, we don't get 3. So the answer is 6 and 3. Since what you want is negative, the bigger one has to be negative. You can check your outer would be 3x, your inner would be negative 6x, and that does end up being negative 3x. Now here's where we use what's called I'm just checking the book, make sure I get the name right, the zero factor theorem. It says if you have p times q equals 0, then either p has to equal 0, or q has to equal 0, or they both equal 0. So if you have two numbers multiplied together, one of them has to be 0 in order to get 0. So right here we have two factors multiplied together. So in order to get 0, either x minus 6 has to equal 0, or x plus 3 has to equal 0. So to find the solutions, you're going to take each factor and set them equal to 0. So the first step is you set everything equal to 0, then we factor, and then we set each factor equal to 0. And then we have two little baby equations, and we solve those. We add 6 to both sides, so you get two solutions. Typically when it's quadratic, you get two solutions. The only time you won't get two solutions is if they're both the same. Like if I had x plus 4 times x plus 4, you would just get x minus 4, because each of these little equations would give you negative 4. So we'll get lots of practice with this right now. So find the roots of this one. This one looks a little different, but we want to do the same thing. We're going to set it all equal to 0. So I'm going to bring this over there. So we're going to get 4x squared. I'm adding 4x squared to both sides, minus 25 equals 0. Now we can take a 4 out, and we're going to get an x squared. Actually, you can't take a 4 out of there, that's silly. This is the difference of two squares. So you're going to factor it as 2x plus 5, 2x minus 5. Hopefully you recognize the difference of the two squares. The 4x squared is a perfect square because you have 2x times 2x. and the 25 is a perfect square because you have 5 times 5. It's a difference, so it's going to be 2x plus 5, 2x minus 5. We have our two factors. You set each one equal to 0. 2x plus 5 equals 0. 2x minus 5 equals 0. Solve them. 2x equals negative 5. X equals negative 5 halves. And over here, 2x equals 5. X equals positive 5 halves. So your two roots, or solutions, are negative 5 halves and positive 5 halves. Let's keep going. Find the values of x that satisfies. That's the same thing as find x, or find the root, or find the solution. You do the same thing on all of these. You set it equal to 0. We like to have the x squared term positive for factoring purposes. So I'm going to add x squared to both sides. So we get x squared plus x minus 56 equals 0. And then we factor them out. So you get x plus x minus. We know that because the last sign is negative, so we know the signs are going to be different. When we say what times what gives me 56, and when I subtract them, I get 1. Well, that would be 8 and 7. You want the 8 to be positive because you want to end up with a positive number in front of the x. Now we have our two factors. We set each factor equal to 0. And we solve those. So we get x equals negative 8. X equals 7. And those are your two solutions. Aren't these kind of fun? Alright, last problem I have for an example, and then I want you to try the practice problems with guidance. So we set this equal to 0. 3x squared minus 6x minus 9 equals 0. This one's slightly more challenging because you'll notice there's a coefficient in front of your x squared term. That's 3. But fortunately, he can be factored out. So we're going to take the 3 out, and we're left with x squared minus 2x minus 3 equals 0. Once that's factored out, we can keep factoring. X, x, and 3 times 1 is our only combination here. The 3 is going to be negative so that we get a negative 2. Now it looks like we have 3 values, 3 factors. But when we go to set them equal to 0, we get 3 equals 0, and that's not true, so you just cross that out. Or you can divide both sides by 3 and it goes away. So we're going to get x minus 3 equals 0, x minus 1 equals 0, x equals 3, and x equals 1. And of course I didn't mention this, but you can check your solutions to make sure that you got it right. So you can bring your numbers up here, put them in for x, and you should get 9. If you don't get 9 when you put them in here, then you did something wrong. Okay, these are from your practice problems. So in your book, so I'm really helping you out here on your homework, and that way you can make sure you get it, and then if you don't, you have a video to watch. So why don't you can either copy these down or get your book, turn off, pause the video, and then come back after you've solved them to see if you got them right. Or, I guess you could look in the back of your book. Alright, here we go. Let's solve these. Hopefully you did these by yourself first. X squared plus 5x minus 24 equals 0. You want to add 5x to both sides, subtract 24 from both sides. Factor them. X, 8, 3 plus minus x plus 8 equals 0. X minus 3 equals 0. X equals negative 8. I'm doing these a little bit faster. X equals 3. And then you can check them to make sure they're correct. Alright, last one. X squared, add 8x to both sides. Subtract 48, is already there, equals 0. Factor these. X, 6, we need, let's see, we're going to need, what times what gives me 48? Oh, they're getting tricky here on us. So it's going to be 12 and 4. Did you think of that one? And it's going to be plus and minus because we need our bigger one to be positive, so outer would be negative 4x, inner is positive 12x, that gives us 8x, so we get x plus 12 equals 0, x minus 4 equals 0, x equals negative 12, and x equals 4. So hopefully you got all that, and make sure you use the help board. That is it for lesson 88.